Welcome back to Math for Technology. We have moved into chapter 8. We're working on vectors and oblique triangles for trigonometry. So we're continuing on the idea of vectors. Last section we figured out what the resultant vector was by drawing them. This time we're going to move strictly into using trigonometry. So I have two vectors, A and B, and they happen to be on the same axis, so one's going up and one's going down, you can see. Find the magnitude and direction of the resultant vector. So last section we would draw it, and I'll go ahead and draw it just to kind of make the change over. So I have one vector, and I'll do A in green. It's at 90 degrees, so that means it's going straight up, and it has a magnitude of 30 units. Then I have vector B, which I'll do in red, which is at 270, so it's going straight down, and it has a magnitude of 43.6 units. So if the object is in the center and I have one force pushing up at it and one force pushing down at it, since the magnitude of the 43.6 is greater, it's definitely going to end up more down than it is up. But let's figure out how much more down. So in the last section we talked about how we would do the Pythagorean theorem, and then we turned that into an actual formula. So what we're going to do here is think about what that was. So to find the vertical axis, which is AY, we figured out we take the magnitude and multiply it by the sine of the angle. And then to find the x, or the horizontal component, we do the magnitude times cosine of the angle. So I'm going to go ahead and do both of those. This is going to get us to the Pythagorean theorem. I'm then going to do the same for b. So I have b of y is 43.6 times sine of 270. And then I'm going to do it for the x. And again, I just realized I transposed those two numbers, so let's fix those. This would be cosine of 270. So go ahead and plug those in. So 30 times sine of 90 gives us 30. And 30 times cosine of 90 gives us 0. 43.6 times sine of 270 gives us negative 43.6. And 43.6 times cosine of 270 gives us 0. So what we can figure out is, now what we do is we put together the components. So I'm going to add the x's and add the y's. So if I add the y's, I end up with a new one. My resultant y, 30 plus negative 43.6 would be a negative 13.6. And my resultant x, 0 plus 0 is 0. That makes sense based on what we talked about. It's going to end up going, it's not going to go sideways, that's the 0, but it's going to end up going more down, and negative 13.6 makes sense because that force is 13.6 units greater than the upward force. So now what I'm going to do is use my Pythagorean theorem to find the side length, which if I did the Pythagorean theorem I'm going to get 13.6. So that's my magnitude. And if I do my inverse tangent, I can tell it's going down, so my angle is going to be, so we're supposed to do it without that, so let's go ahead and do it. I was going to skip that step, but let's remember it was the absolute value of y, negative 13.6 over 0. Now remember, that's the ratio. So that's telling us undefined, and if I tried to plug that in the calculator it wouldn't work. So its tangent is undefined at 270. So there is a little bit we just have to know. So there's our magnitude and our direction. So the difference now is we're going to use these equations that we found before. We're going to do each of them, combine the y's and the x's instead of drawing them out in right triangles. Okay, so I'm going to go ahead this time and put them stacked. Instead of going vertically, or horizontally, I'm going to go vertically. So I have my c of x is going to be 66 times cosine of 180, and my d of x is going to be 59 times cosine of 270. I have my c of y is 66 times sine of 180, and my d of y is 66 times sine of, oops, wrong angle, 270. Okay, so 66 cosine of 180 is negative 66. 59 cosine of 270 is 0. So when I add up my x components, I get negative 66. 66 sine of 180 is 0. 66 sine of 270. Oh, I plugged in the wrong number again. So let's fix that real quick. This should be 59. So 59 times sine of 270 is negative 59. Go ahead and add those. We're going to get negative 59. So I have my two component parts. So now I'm going to do, to find the magnitude, it's the square root, negative 66 squared plus negative 59 squared. So I have approximately 88.5 units. And then to find my theta, we're going to do inverse tangent, the absolute value, negative 59 over negative 66. So inverse tangent of 59 divided by 66 gives us an angle of 41.8 degrees. So I know my magnitude and my direction. Now this one you might notice doesn't have the theta. It only gives us the AX and the AY. So really what they've done is they've backtracked a little bit. We're just going into a right triangle. I know this is vector A. They've given us, we have 44 for that, for the horizontal component, and 67 for the vertical component. So instead of having two different ones, they're just telling us they're at a straight at 0, and they're telling us it's really at 90 degrees. So to find the magnitude and direction, you don't have to do any adding. We're just going to go straight to the last step on the last one. So the magnitude is simply the square root of 44 squared plus 67 squared. So that's approximately 80.2 units. And the direction is the inverse tangent of 67 over 44. Remember the y always goes on top. Inverse tangent of 67 over 44. And we have a direction of 56.7 degrees. So this one's done the same. So to find a of x, we're going to go 5 times cosine of 70. And to find a of y, we're going to go 5 times sine of 70. For b, we're going to do 10 times cosine of 70. And for y, we're going to go 10 times sine of 30. This should be 30. So you can see how easy it is to mix them up because I've done it a couple times, so make sure you're keeping track. So A's has to be 5 and 70s, and B's have to be 10 and 30s. So quick check before I plug them in. 5 cosine of 70 is approximately 1.71. 5 sine of 70 is approximately 4.70 when I do the rounding. 10 cosine of 30, 8.66. 10 sine of 30, it's a whole number of 5, but we'll go ahead and add. So the 1.71 plus 8.66 gives us 10.37, 9.7. So to find the magnitude, square root 10.37 squared plus 9.7 squared. Square root that. So we have approximately 14.2. And for my direction, inverse tangent of 9.7 over 10.37. Approximately 43.1 degrees. Okay, so you've seen that a couple times. Hopefully that's getting easier. So have some situations. I have, not sure what that is sticking off of a board or a wall, some type of metal. And so I have two vectors. I have one going 2 kilonewtons at 40 degrees from due south, and I have another one going 3 kilonewtons, 60 degrees from due south. So I want to put those together. So really, it's no different. It's just drawn as a picture. So we'll just go vector. I'm going to name them real quick. So we'll make this be the C vector and this be the D vector. So to find C of x, I'm going to go 2 times cosine of 40. And to find C of y, 2 times sine of 40. And for D of x, 3 times cosine of 60. And for D of y, 3 times sine of 60. $1.53, $1.29, 1.5, 2.60, 3.03, 3.89, square root 3.03 squared, 3.89 squared, square root that, 4.93 for our magnitude, and for our direction, inverse tangent of 3.89 over 3.03. $52.1 degrees. Okay. Okay, on this last one we have a situation. An airplane is flying at 590 miles per hour with a heading of 74 degrees. A 56 mile per hour wind is blowing from 214 degrees. Find the ground speed, the course, and the drift angle of the airplane. So when we're talking about these degrees, they are talking from standard position. Not that that really matters at this point. So what we're going to go ahead and do is just like we've been doing. So the airplane X would be 590 times cosine of 74 and the airplane's Y would be 590 times sine of 74. And then we have the wind. So the wind's X would be 56 times cosine of 214. And the wind's Y would be 56 times sine of 214. So let's go ahead and plug those in and get those numbers. So I have negative 46.4, negative 31.3, $162.6, $567.1. So we'll go ahead and add those. 116.2, 535.8. Okay, so what we're going to do now is think about what's going on. We're going to go ahead and find the ground speed. So we're going to find the magnitude. So the square root of 116.2 squared plus 535.8 squared square root that. So we have a magnitude, which is the ground speed, of 548.3 degrees. So this is the ground speed. Okay, so then we're going to go ahead and find the course, which is our theta. So we're going to do inverse tangent of 535.8 over 116.2. So we're going on a course of 77.8 degrees. So that's the course they're asking for. Now it says, what's the drift angle? Well, so it originally was going at a 74 degree heading, and now it's going on a 77.8. So the drift angle is simply the difference between them. So 77.8 minus 74 gives us a drift angle of 3.8 degrees. Okay, so with that, we'll go ahead and we're done with the section, and try your assignment, and I'll go ahead and move on to the next video. Have a good